Okay, so concentrated solar power is also called solar thermal electricity, where instead of doing what the photovoltaics do, converting light energy into voltage or current, concentrated solar does exactly what it says. It uses some kind of a device to concentrate the solar energy to heat something. Obviously reminds you of the old human beings who were using some sort of a solar magnification to start fire, or the Greeks who used it to light the Olympic lamp, and I think Leonardo da Vinci used it to heat swimming pools, and so on and so forth. We will see an example of how these devices actually work. And Spain and US are the two that are essentially running these systems. The ranking and results by 2050 is at 25. The reduced CO2 compared to some baseline or business as usual is 10.9 gigatons. The net investment needed to establish and operate it over 30 years is 1.32 trillion US dollars, and the net savings that would result over these 30 years of operation of such a system is $413.9 billion. Obviously, the efficiency is going to be low because you are converting part of the solar energy and focusing it onto something, in this case the parabolic trough, which is focusing the energy on this absorber tube, which has, let's say, a fluid flowing through it, and then that's going to be taken out either to drive a turbine or do some other way of converting this concentrated solar power into some use of energy. Here is it's a dish that is concentrating energy onto a receiver engine, and then that's going to produce some sort of energy that will be used for various applications. This is the absorber tube and concentrator, so the mirrors are focused on these concentrators, the absorber tubes, which are shining the energy onto this absorber tube, which then either heats the water, creates steam, drives a turbine. And the advantage, of course, over the photovoltaics is that this can give you storage. Heat can be stored more efficiently in these large scales than a battery. So at least for let's say up to 10 hours or so. So then the energy can be made available when the sun is not shining. So you have the intermittency problem taken care of to some extent at least. This is the other design where there are what are called heliostats, which follow the sun. So you're always getting some sunlight, and then you are concentrating it onto a solar tower. So the idea is pretty clear, concentrated solar power. This is the Crescent Dune Solar Energy Project, 110 megawatt solar thermal plant near Tonopah, Nevada in the US, western US. It's also a molten salt storage plant capable of holding 1.1 billion kilowatt hours of energy. So the molten salts are good for keeping the heat. Once the energy is used to melt the salts, they can keep the heat for a while, much better, much more efficient than, let's say, just water. 10,347 heliostats circle a 640-foot tower at the center and have a combined surface area of 1.28 million square feet, fairly large area. The $1 billion plant produces electricity at 13.5 cents per kilowatt hour, higher than wind and solar farms to be sure. However, Tonopah provides steady baseload power, which in turn enables intermittent energy from renewable wind and solar to be seamlessly integrated into the grid. But this baseload power often includes running the heating system with other fossil fuel based energy sources like natural gas, which actually have carbon emissions. So this is not as clean as the photovoltaics. Plus, this is more expensive, efficiency is low, but it's expected that the systems will keep getting better. So looking at the overall impact, then concentrated solar power comprised 0.04% of the world electricity generation in 2014. So really a small percentage, and as we said, only dominated by Spain and US. Despite slow adoption in recent years, this analysis assumes that CSP could rise to 4.3%. So that's a tenfold increase, 100-fold increase of the world electricity generation by 2050, avoiding 10.9 gigatons of carbon dioxide emissions. Implementation costs are high at 1.3 trillion, but net savings could be 414 billion by 2050 compared to some baseline scenario or traditional source of energy, and 1.2 trillion over the lifetime of the technology. Okay. An additional benefit of CSP is that it can easily integrate energy storage, allowing for extended use after dark. So it's kind of an integrated energy storage system with solar. So has definitely some advantages as well. So if technology improves and the costs go down, then it is expected to become a almost a 5% contributor to the total global energy production by 2050, 4.3%. Again, those are estimates and depend on various barriers that we talked about in terms of governance, space for implementing them. There are also issues of birds getting fried by this very high energy that is being concentrated. Some companies supposed to have come up with protection against birds, so that is a big part of the barrier that has to be worried about as well in terms of protecting other species from getting burned by these systems. Okay.